ever pondered what it would be like to board a plane in New York and disembark in London just an hour later? Imagine the possibilities of a world where distance is no longer a barrier, but merely a minor inconvenience. Welcome to the future of modern family aviation, a future brimming with the promise of hypersonic travel. In our fast-paced, interconnected world, the need for speed is paramount. We're not just talking about shaving off a few minutes here and there, we're talking about a paradigm shift, about hurtling through the stratosphere at over 5 times the speed of sound. Picture this, a Mach 5 hypersonic passenger plane, a marvel of human innovation that could revolutionize global transportation as we know it. This isn't just about faster flights, it's about bridging cultures, fostering global unity and propelling human progress at unprecedented speeds. But how does this lofty idea transform into reality? What makes hypersonic travel feasible? Stick around as we unravel the science behind this audacious concept. Hypersonic travel sounds like a concept straight out of a sci-fi movie, but the science behind it is quite real. Now, let's start by understanding what we mean by Mach. It's a term used in aviation to measure speed, named after Ernst Mach, an Austrian physicist. When we say Mach 1, we're referring to the speed of sound, which is about 768 miles per hour at sea level. So, when we talk about Mach 5, we're talking about traveling 5 times the speed of sound. That's faster than a speeding bullet. But how does one achieve such speeds? This is where the fun physics come into play. Firstly, the aerodynamics of the aircraft is very crucial. The design needs to be streamlined to reduce drag. That's the force that opposes an aircraft's motion through the air. The less the drag, the faster the aircraft can go. Then there's the question of temperature. As an aircraft moves faster, the air in front of it compresses, and this compression generates heat. At hypersonic speeds, this heat can be intense enough to damage the aircraft. So the materials used in the construction of the aircraft must be able to withstand these extremely high temperatures. And don't forget about fuel efficiency. Achieving and maintaining hypersonic speeds require a lot of energy, and that means a lot of fuel. The challenge is to find a fuel source that is both powerful enough to reach these speeds and efficient enough to maintain them. But there are challenges in achieving and maintaining hypersonic speeds. For one, the heat generated at these speeds can cause structural damage to the aircraft. Plus, the sonic boom created by breaking the sound barrier can cause noise pollution, a problem that engineers are still trying to solve. So, we've got the science down, but what does it take to make this dream come true? Turning the dream of hypersonic travel into a reality is no small feat. It is indeed Herculean. The journey towards this high-speed future is paved with technological advancements that push the limits of what we currently deem possible. Let's start with one of the most critical aspects, materials. To withstand the tremendous heat generated during hypersonic flight, we need materials that can withstand temperatures exceeding 2000 degrees Celsius. That's hotter than molten lava. Recent advancements in material science, such as the development of ultra-high temperature ceramics, are promising, but we still have quite a long way to go. Next up is fuel efficiency. To achieve Mach 5, or 5 times the speed of sound, we need rocket-like propulsion. But rockets aren't exactly known for their fuel efficiency, are they? However, with the emergence of scramjet technology, which allows engines to breathe air, we're making strides towards more efficient fuel usage. And let's not forget about aerodynamics. At hypersonic speeds, the rules of the game change significantly. We're no longer just dealing with drag and lift. We're also grappling with shock waves and intense heat. So our understanding of aerodynamics needs to take a quantum leap forward. Yes, the hurdles are high and the challenges are complex. But remember, every great innovation in history began as a daunting challenge. And with the rate at which technology progresses, these hurdles might soon be a thing of the past. So, are we on the brink of a new era in aviation and air travel? Just imagine hopping on a plane and being halfway around the world in less than 3 hours. That's the promise of hypersonic travel. We've discussed the growing global need for speed, the mind-bending science behind it, and the hurdles we need to overcome. But with continuous technological advancements and research, these challenges can be surmounted. While hypersonic travel may currently be a concept, with the right technological advancements, innovative research and committed funding, it might just be the future of global transportation.